So basically, so you know we are in the big data world. In neuroimaging, it means that the amount of data which is used to publish a paper is dramatically increasing. So back 10 years ago, probably you would need a few megabytes to publish a paper in neuroimage in that case. Now we are between 10 and 15 gigabytes, sorry, and still counting. So there are no valid reason for this curve to stop growing in the next years. So this is coming from mainly two causes. The first one is the generalization of databases, including multicentric databases that allow to conduct studies with bigger N's. So you have examples here of studies in databases that I'm sure you've heard about, so which allow students or researchers to access a lot more data and subjects. The other effect is the increase of the resolution of this data. So what you have here is an example of the big brain, which was published almost 2 years ago now by a joint work between Katrina Mutz in Germany and Alan Evans in Canada. And what you can see, this is the first atlas of the brain with a resolution of 20 microns isotropic. So if you're familiar with MRI, you can appreciate that you can see here quite different structures than from an MRI. And the point which is also interesting to us is that this data set is close to 1 terabyte. So we are clearly, when we want to use this kind of data set, we are clearly in another scale. So imagine that, for instance, MNI 152, an atlas that you may use when you use FSR or FreeSurfer, is replaced by this, then you understand that data is really exploding. What tools do we have to, if you like the video, you can go to the website, Google CBRAIN and you can enjoy it. So what tools do we have to answer that? Well, basically we can distribute. We can distribute what? Data acquisition and integration. And I will talk about the LORIS platform developed at McGill. We can also distribute data processing and simulation. I will talk about CBRAIN and the virtual imaging platform. And finally, so this is mainly the outline of my talk. And finally, we have to keep, in my opinion, interoperability in mind. And I will, as a conclusion, give a few examples of interconnections between these platforms. So LORIS is a web-based data management system for multi-center studies. It's been published almost 3 years ago, but actually it's been used since 15 years. This is the original study that motivated the development of LORIS. So it's a study for the normal brain development, which involved a few, between 10 and 15 centers in the US and Canada. You can see here the different modalities that were required, and it was a longitudinal study. So each modality was acquired at 5 different time points. So basically what LORIS can do, it's mainly three things. It handles the data workflow from acquisition to processing. So first of all, at the top left, you have acquisition management features. So it has a whole set of project management tools. It can do quality control. It can check for double data entry. It has visualization tools. And also it can store behavioral data, questionnaires that I should issue to subjects, etc. Then it's a repository of images, so it's basically a database of images. You can browse, search data through the online interface and download the results of the study, of the search. And it's also linked to analysis pipelines, either internally for, let's say, light transformations of data formats, and also externally, in particular, it's linked to CBRAIN for pipelines that require high performance computing systems. So it's been a long development effort of 89 years since the beginning of the 2000s, and it's been used in production quite largely. So these are just a few snapshots of the interface. So this is a recruitment dashboard where you can see at the top if you have a target number of subjects in your study, you can see where you are in the front page, you can see different statistics about the data that has been acquired. There is a QC interface which allows you to say this is junk, don't use it in the study, or this is acceptable. This is all done online, so the visualization is also integrated in the web portal. And recently it has been extended to be mobile friendly, so that people can either input or query data from phones and tablets. I was saying that it's used largely in production, so this is a snapshot of the different projects that are using LORIS nowadays. So you can see that it's quite widely distributed around the globe. The second tool that I wanted to talk about is CBRAIN. So LORIS is on data management and data storage. CBRAIN is the processing tool, which is quite largely linked to LORIS. So again, it's a completely web-based tool for distributed computing. So this is the CBRAIN architecture in a nutshell. So you have a classical three-tier architecture. At the bottom you have the different resources, so mainly computing resources, so clusters and clouds. And at the left you have data storage resources. So it can be also any kind of, there is a flexible plug-in mechanism to access data in computing systems. So it can be any kind of data access protocols and systems. In the middle there are a set of APIs that can talk to these systems. And these APIs expose like a uniform view of these resources to the core of the CBRAIN application. The CBRAIN portal has catalogs to record the files, permissions, access rights to the computing resources. It has visualization tools. And this is also the place at Derive, tools and VMs. This is a place where the scientific applications are run. And finally, at the top of the diagram, you can see the two ways to access CBRAIN, either directly through the web interface or through an API, which I think is quite important in a world where we are supposed to make services interoperate. So you can basically write scripts, or you can access CBRAIN also through an API. What are the main features, the main CBRAIN features in a nutshell? So it's a web platform. The storage is completely distributed, which I think is still original even now in 2015. Still, it exposes a transparent view to the user, so you see only one file catalog, one file system, but it's distributed in the backend. The box that I highlighted here, in my opinion, is also quite unique to CBRAIN. It's a complete system, so to the contrary of other read middleware, where you need to first install Globus on the resources and then install that thing and then install another dependency, CBRAIN just comes as a standalone application. Okay, so I think it's quite unique that with only one application you can address computing resources and storage and the web portal. It's quite flexible. You can easily add your clusters, add your tools. It's, let's say, fairly easily deployed too. If you want to have a proof of it, just come to the hackathon. You can install it on your infrastructure, probably during the course of the day. It also has some features for provenance record, so just to basically identify what has been done with the data and what were the parameters used to derive from the data. Scalability, it's, as I was saying, a full ecosystem. Security is also key to CBRAIN. Sometimes people are scared when we mention distributed systems for health, because you think that the data is going to be spread all over without any security or privacy concern. In CBRAIN, this was integrated from the beginning by design, so you can basically specify what are the constraints on your data. If you want the data to be only stored at a particular hospital, for instance, to stay on a few sites, or to be able to travel all over to be processed on more powerful machines. So CBRAIN is based on, well, mainly uses the Canadian computing infrastructure. As I was saying, it can be installed and deployed on mainly any kind of cluster. A feature that we've added recently is the ability to include virtual machines and, I should say, to containers, Docker containers in the system, which is a nice way to add new applications. Okay, because now CBRAIN administrators, or I should say application developers, could just provide to the core CBRAIN team a disk image or a Linux container containing their application with all the dependencies, and then CBRAIN will take care of deploying these virtual machines or containers either on clusters, we have clusters which support virtual machines and containers, or on clouds. And then users could access these applications through virtual appliances. That's just an example of a recent experiment we've made running CBRAIN on Amazon Web Services. So again, it might have some clinical or commercial applications. So we basically executed FSL Vet, FSL First, and FSL Fast on Amazon, and we just measured the performance and the cost in dollars, real dollars, to process a number of subjects. So we can have a complete CBRAIN installation on Amazon now. Again, the user base is quite widespread. So there are 60 labs, more than 200 researchers from 17 countries using CBRAIN regularly. It's getting open source actually tomorrow. Tomorrow we have the first open source release of CBRAIN. So again, come to the hackathon if you want to have a primer on it and install it on your machine. I didn't mention that LORIS was open source. It's been also open source for a few years already. So you could download and contribute to this project freely and openly. CBRAIN has a number of tools included, mostly from neuroimaging, including SPM, some tools from FSL, FreeSurfer, CVET, which is the surplus extraction and segmentation pipeline developed at the MNI. And again, so this is, I'm saying that it's quite extensible. You may want to try it on your tool, and again, if you want to do this, come to the hackathon, and I will be very happy to help. The final system that I would like to mention is a platform that we've developed at CNRS, but with other groups in France. So we are shifting a bit worlds now and infrastructures. It's called the Virtual Imaging Platform, or VIP. So basically, VIP has a web portal at the top left, which aims at completely hiding the infrastructure. In this web portal, you can basically transfer files to the European grid infrastructure, which is also an open infrastructure for scientific research in Europe, which is, by the way, openly accessible. So if you have like big workloads to compute, you can access this infrastructure freely. And on this web portal, so we can transfer files and we can access applications. We tried, it was a few years ago, we tried to have an iPhone at that time like interface with just showing the main applications like this. So as I was saying, at the right here, it's, this portal is supported by EGI. It's available in Grid, which is the infrastructure developed and headed by Giovanni Fazzoni. And it consumes something like, our users consume something like 30 CPU years every month. The main applications of VIP are initially in a Monte Carlo simulation for cancer therapy, but by extension to also other applications. Neuroimage analysis was not the initial motivation, but we have included quite a few tools through a few projects. And image simulation, so we have people simulating echography, PET, MRI, of course, and CT in the platform. We have quite a wide user base. It's really an open platform, so you can go to this URL, create an account, and start launching your FSL or FreeSurfer jobs right away. And we have to date more than 700 registered users who are quite active. Again, the tools available, so I mentioned a few tools in simulation, so it could be medical simulation or image simulation. some neuroimaging tools and also other tools that we include here and there from, that are local tools from students and other researchers. Before finishing, I would like to leave you with, I think maybe, well, it's a work in progress, but a vision for the evolution of this platform. So you've understood that I've shown 3 platforms that are in production, that are well established, with quite some users, of course still developments ongoing, but these are established tools. I think that the next years we'll see the interconnection of such different platforms. Okay? During the last 10 years, such high throughput computing and storage platforms have been developed. Now it's really time to connect these platforms together to see new original applications emerge from that. Currently, the main applications are, you may want to use such platforms if you need to access computing power, or if you need to store a lot of data or to query databases. But there are, I think, much more different applications to that, much more ambitious applications to that. So if we could connect some of these platforms together, so including CBRAIN, LORIS, VIP, other platforms that we are involved with France Life Imaging, which is a national infrastructure project in France, and maybe others, then we could have easily pipelines going from one side to the other, one platform to the other. You've seen actually that the list of tools available today in CBRAIN and in VIP are quite similar, and it's a pity that people integrate these tools over and over. In CBRAIN, in VIP, also in N4U, in CATI, in you name it, in a number of platforms you have people integrating pipelines, the same pipelines over and over. And I think this pipeline should be able to flow from one platform to the other. We should be able to exchange tasks. When one platform is too loaded, tasks should be able to migrate to another platform, or when a user doesn't have the right to use the computing resources on one platform, tasks should go to another platform, users and data sets, of course. Basically, this involves quite some research, but mainly to agree on common APIs, to invoke pipelines, to retrieve analysis, and to query data, and to agree on common repositories of data, but also tools that could be deployed on these different platforms. So when we have such a network, you could envisage, and this is just a small use case to leave you with that, you could envisage that you have this experienced scientist with glasses that runs an experiment, let's say on CBRAIN. It could be another platform of the network. So an experiment means take data from CBRAIN, for instance, select a set of tools and parameters, and process this data with tools. And maybe it has a few tasks, a few iterations, until this person has a result which is suitable for publication. And then instead of just writing the paper and putting some screenshot or I should say some advertisement of the result in the paper, then the result that was computed in CBRAIN should be published in a repository, for instance based on digital object identifiers, and the paper, at step number 3, could refer to this DOI, or to the actual experiment that was done in CBRAIN. Then you have another user, let's say a PhD student that just started his thesis or her thesis, who reads the paper from this experienced scientist and say, hey, this is mostly what I need to do in my thesis. That would be great if I could access this data, access the actual tools that were used to process the data, and if not replicate, at least get a hint on how to reproduce this experiment for my research. So then, at step number 2, the PhD student would use this DOI to resolve this DOI to the actual URL or URI of the experiment in CBRAIN. So the problem is that when this PhD student requests access to CBRAIN, here I'm talking about, let's say, one CBRAIN instance deployed in Canada, he is denied to access the computing resources in Canada, because maybe he is from Europe. So CBRAIN could redirect the user to VIP and say, I'm not able to grant you access to some computing resources, but hey, here is a platform where you can actually use to replicate this step. Problem is that maybe the tools are not the same. I mean, on CBRAIN there was a version of FSL of Researcher or CVET which is not available in BNP, but thanks to this interoperability that I've shown before, some tools and data will be exchanged between the two platforms so that the student can actually replicate the experiment in the end. So that's not working, but we are developing, we have a few blocks and a few bricks towards this, and this is where we are going. So as a conclusion, maybe I'm 1 minute late, sorry for that, but the main message I wanted to convey here is that LORIS, CBRAIN, and VIP are available for distributed data management, data analysis, and simulation. So feel free to download them, modify the code, install them on your platform, experiment with them, report bugs, etc. And the question, what about you? I mean, you being the students or the HPP, project, are you going to reuse existing platforms? Or maybe you think that your research deserves to redevelop something from scratch, but then what you developed, is it going to integrate with existing platforms so that we can, even if we don't share the same code base, at least exchange tools and data, if not analysis, which are really the core of I guess, what we are doing. So thanks a lot. If you have any questions, please happy to answer.